Okay, we're going to take a look at a question where we compare distributions. We talk about the shape, we talk about the centers, and we talk about the spread. So we've got a situation here where we've got a machine that's producing normally distributed snack bars with a mean of 41 and a standard deviation of 0.8. So basically that graph looks like this graph over here, right? Which has a mean of 41, and 3 standard deviations away is 43.4, 3 standard deviations away over here is 38.6. So we get a graph that looks like this. Now if you want to do a quick calculation of the range, which is one of the things that you want to do because that has to do with spread, then the range of any normal distribution graph is just 6 times its standard deviation, because you're looking at the entire range, 3 on one side, 3 on the other, so 6 times 0.8, which is 4.8. We're going to compare the ranges, we're going to compare the means and medians and modes, and we're going to compare the shape. So the first thing, the easiest thing probably to do is to do shape, because that doesn't take too much of anything other than just eyeballing it. We need to know what the characteristics of our normal distribution curve are, and that is that they're bell-shaped, they're symmetrical. The mean and the median and the mode are all in the same position, and are all in the center position of the graph. So that hasn't been mentioned here, but you probably would want to mention that around the center of the graph. Now Sarah's graph, if you take a look at it, it's bimodal, right? It's pretty much irregular shape. It doesn't really take a particular shape of any kind, so we call that irregular. But it's somewhat symmetrical, because if you take a look and you go down through the middle of this graph, it's not perfect symmetry, but it's not bad. So somewhat symmetrical, but it's not bell-shaped. So that's just kind of a summary of how you can talk about the shape. You don't need to write a book, but that just gives us some things. You might be able to come up with some other things around the shape, but that kind of highlights the idea that normal distribution is bell-shaped, it's symmetrical. The means and medians and modes are all in the same place in the center of the graph, and then you compare that against Sarah's graph. Now the second thing is the centers. Well, in a normal distribution graph, we know that the mean, the median, and the mode are all going to be in the same place, and in this case they're all going to be 41 grams. Now we're going to have to compare that with Sarah's data. So Sarah's graph is not going to have that same situation. And in order to find out exactly what her situation is going to be, we basically need to do some work with a Casio calculator or a TI around how we're going to calculate the mean and the median. So we know where the modes are. So what we do is we take a midpoint in each one of these columns, bars, if you will. We take the midpoints, approximate them as best you can. So in this particular case, 38.2, so this looks to be about 38.3, and so that one. And then the next one, 2, 4, 6, looks to be about 38.7, and the next one, 39.3, and so on. So that's how they go. They go that way, 39.7, 40.3, all the way till you get to 42.23. That should be 40. Yeah, so that would be 42.3, and it stops there. So on your calculator, in your list 1, under stat, you're going to put 38.3, 38.7, 39.3, 39.7, 40.3, 40.7, 41.3. Now this graph does not have a 41.7 bar, so we're just going to skip that, and we'll go to 42.3, and we're done. All right. Now, if we go over to list 2, what we're going to put over in list 2, and this is very important if you're going to calculate the mean and median and mode for this particular graph, is you need the frequency. So the frequency is this over here tells me how many of each we have. So we have the first bar, there's 10 and 10, and then 80 of those, and then 40 and so on. So we're going to put those values in to match up against the column. So we've got 10, 10, 80, and then we've got 40, 50, 80 again, that's the other mode, and then we've got 20, hopefully these match up, and 10. Right, both columns should stop at the same place, and then we're going to calculate that. Now with a TI, or a Casio, not the TI, but with a Casio, we need to do a setup. And that first row there should say list 1, and the second row, which is our frequency, where we've got the frequency, shouldn't say 1, it should say list 2, because that's where we've got our frequency. So we're going to hit F2 and then a 2. So this row needs to say 1 var frequency list 2. And then we can execute and we can calculate that for one variable, because it's only one variable. So there we're going to have our mean, that's the first thing that shows, the x with the line over top of it. This x n minus 1, that's our standard deviation, 0.85. Keep going down, you get your median. So this is the data for Sarah's graph. So if we take a look, Sarah's graph looks like this. So the mean, the median, and mode for the machine for the center for the normal distribution is 41, but for Sarah's, if we do this method, we get a mean of 40.1, a median of 40.3, and we have 2 modes in different positions. Now you can check out what those 2 modes are just from the graph. But you can see that in comparison with the normal, the mean, median, and mode are all in the same place, whereas in Sarah's, the mean's a little bit smaller than the normal position. It's by about 0.9, and the median is 40.3, and then we have modes. They're all in different places along the graph. Now, we need the standard deviation. So remember, the standard deviation for this is this value right here, 0.85. And so if we want to compare the range, 6 times 0.8 was the range of the normal, 4.8, and then 6 times 0.85 is the range of Sarah's data. So you do a comparison of the ranges and the standard deviations, talk about spread. So Sarah's data is a little bit more spread out. So this is the calculations you need, the mean and the median, the standard deviation, the spread, and you do a comparison. Now, if you feel like you don't have enough, now that you've got the mean and the standard deviation for both sets of data, you could, make a statement. What's the probability that x is, greater than 41.5? If you want it just to sort of do another comparison, you could do that for the normal graph. You could work it out, and now that you have mean and standard deviation for Sarah's graph, you could roughly sort of figure out what that would be from her graph. But this would be enough. Shape, centers, spread, right? Which is your range and your standard deviation.